This video will cover the reaction of alcohols with HBr. This reaction takes advantage of the strong acidity of HBr to protonate the alcohol and make it a better electrophile. Remember that we discussed that acidic solutions affect the nucleophilicity of many nucleophiles because they're also strong bases. However, the acidic solution does not affect the nucleophilicity of the bromide ion because the bromide ion is a weak base, even though it is a strong nucleophile, because it is the conjugate base of the strong acid HBr. Reacting an alcohol with HBr protonates the alcohol, allows the bromide to attack as a nucleophile and replace the hydroxyl group, producing an alkyl halide. The mechanism of this reaction depends on the structure of the alcohol. When the alcohol is tertiary, and most of the time when it's secondary, this occurs through an SN1 mechanism. Let's look at an example. If we treat this alcohol with HBr, the first step is protonation of the alcohol with the strong acid. This forms water, which is a good leaving group. The water then leaves to produce the carbocation. The bromide ion that was formed in the first step then attacks the carbocation to produce the alkyl bromide. Remember that when we form a carbocation, any stereochemical information that was present in the original alcohol is lost. Therefore, if we start with a chiral alcohol, such as this one, we will end up with a mixture of products, a racemic mixture. Additionally, because a carbocation is formed, we also have to consider the fact that rearrangement can occur if a more stable carbocation can be accessed. While tertiary and most secondary alcohols undergo an SN1 mechanism, primary alcohols cannot form a carbocation and therefore tend to go through an SN2 mechanism. So, if we treat this alcohol with HBr, the first step of the mechanism will look the same as the previous reaction, protonation of the alcohol to form a better leaving group. However, the next step will be attack of the bromide ion, because a primary carbocation cannot form. This produces the alkyl bromide product. What this means is that primary alcohols will see an inversion of stereochemistry at the alcohol center. For example, consider this primary alcohol. Remember that D stands for deuterium, a heavy form of hydrogen. If we treat this primary alcohol with HBr, this will undergo the SN2 reaction and produce the inverted stereocenter.